Hi everyone, welcome to goclasses. In this lecture, we will study functional dependency, inference, and equivalence. These concepts we will study in this lecture. Okay, so let's start now. First, we will see inference, means what are inferred functional dependencies. Let's see this concept. See, the name itself is telling you inferred functional dependency. Inferred means derived. Okay, this inferred, this infer. What this word means? Infer. You can also call it derive. Which functional dependency you can derive. Okay, which functional dependency you can derive. So what this concept is, let me tell you. Let's assume you have a set of functional dependency. This is your FD set. Let's call it F. This is your set of functional dependency. Let me give you like A determines B, B determines C. Okay, this is your set of functional dependency. This set I'm giving you. From this set, can I infer that A determines C? From this set. Okay, so this is your set of functional dependency. My question is that from this set F, can we infer? Infer means derive. Can we infer that functional dependency A determines C holds? Tell me, can I say that A determines C holds? Can I say yes? The answer is yes, right? Okay, because A will determine C transitively. You already know. A can determine B, B determines C, so A will determine C. Very simple. So I can say that, yes, we can infer from this set of functional dependency, we can infer this functional dependency. Okay, is this clear? So this is your inference. This is the inference, means this is inferred FD. I can say this is inferred. I can say this is inferred by F. Okay, this is inferred by F. From this functional dependency set, this is your set of functional dependency. From this set of functional dependency, you can infer this. So this is your inferred FD. This is your inferred FD by F. Very simple, right? Yes or no? Tell me one thing. From this set of functional dependency, can we infer C determining A? Can we infer C determining A? What about this FD? I am giving you FD that is C determining A. Tell me, can we infer this? Is this inferred? My question is very simple. Is this inferred by F? Is this inferred by F? Tell me, is it inferred? Inferred means derived. Is it inferred by F? Please tell me. This functional dependency. So the answer is no. Yes or no? If you have this set of functional dependency, then you cannot infer this. Yes or no? So I can say this cannot be inferred by F. This cannot be inferred by F. Cannot be inferred by F. Okay. So did you understand the concept? Very simple, right? The concept is quite simple. Which functional dependency you can infer from a given set of functional dependency. This is the given set of functional dependency. From this, which functional dependency we can infer, we can derive. Okay. Now, so you can see if some set of functional dependency is given to you, we are given these functional dependency, and what we want to find out, we want to find out whether this functional dependency is derived from this or not. Okay, so let's assume there is a relation. On that relation, these FDs are holding. Okay, I can say there is a relation on which these FD they hold. Now we want to know on that relation, will this FD hold? Okay, means from these FDs, can you derive this FD? Okay, this is what we want to know. For example, if these FDs are given to you, then you can infer A determining C. Okay, if A determine B, B determine C, if this set of FD I give to you, then you can derive this FD. You can infer this FD. Okay, very simple concept. Now let's see this question. Tell me the answer for this question. This is your set of FDs that is given to you. This is the relation A, B, C, D, E, F. Now we want to know, we want to test whether this FD follows from the set of FD or not. Okay, we want to test whether this FD follows from this given set of FD or not. So tell me, how will you check it? Tell me, how will you check it? Let me know. See, the method number one, what you can do, you can apply the functional dependency laws. Yes or no? What you can do, you can apply the FD laws, right? This is the method number one. Okay, what you can do, you can apply the FD laws. So we want to derive this AB determining C. So tell me, how can I do this? Already it is given that AB determining C. Okay, this is already given to you. AB determining C. This is already given to you, right? Okay, so yes or no? This is given, right? This is given to you. Now, what we want? We want AB determining D. This is what we want. Okay, this is what we want. Now you can see that BC determines AD. Yes or no? BC determines AD. So how to do this? Tell me. This AB determines C. Can I say AB also determines B? This is trivial, right? This is by reflexivity. This is by reflexivity. Agree with me? AB determines B. This is by reflexivity. Correct? Okay. So you can see this FD is given to you. This is by reflexivity. Okay. Now tell me, from these two, what I can say? From these two, what I can say? So this FD, from these two, what I can say? Tell me. If these FDs are given to you, now from these two, what I can say? I can say that AB determines BC. Yes or no? AB determines BC. I told you what we can do. We can combine on the RHS. Agree? Yes or no? We can combine on the RHS, right? Yes or no? We can combine on RHS. What we can do? We can combine on RHS. So you can combine on RHS. Now you can see AB determine BC, and this is given BC determining D. This is given. This is given. So finally, you can apply the transitivity and you can get this. Yes or no? You can apply transitivity and you can get this. Anyway, this is your method number one, but we will not use this method. Okay, we will not use this method. Okay, remember this FD laws. This method we will not use. What we will do? What we will do? See, this is your given set of FDs. Very simple. This is the given set of FD. Now in this, you find out what is AB closure. Because remember what we want to test. See, we want to test what we want to test. We want to test whether this is inferred or not. This FD is inferred or not. Yes or no? Is inferred or not? This is what we want to test. So what I will do, remember, in this I will find what is AB closure. In this I will find what is AB closure. I will check, can AB closure contain D? Yes or no? I will check, does AB closure contain D? So what I will do, I will find AB closure. So AB closure will be what? That will be AB. AB can determine C. Now these three people, what they can do? BC can determine AD. BC can determine AD. Now that's it. Yes or no? Now I can stop here. I can stop here. Of course, if you want, you can go further. If you want, you can go further. But the point is, now you can stop here. Okay, is this clear? So you can stop here and you can say that from this given set of FD. So remember, you can see that in the given set of FD, what is happening? In given set of FD, in given FD set, what is happening? You can see that AB determines D. AB closure contains D. AB closure is, this is your AB closure, A, B, C, D, E. Okay, so what I can say? So AB determines D. Is this clear? Please tell me. So this is the method we will use. Did you understand what is the method we will use? See, we want to test whether this FD you can derive or not. You can derive this FD or not. So what I will do, I will check what is the AB closure. This AB closure, does it contain D? So I will find AB closure here. Here I will find AB closure, and yes, that contains D. So I can say that in this AB derives D. Yes or no? In this, you can see AB can determine D. So that's it. Is this clear? Very simple. So you can see very easily you can do this. All you have to do, just find the AB closure. Find the AB closure, and then you can see that AB can determine D. So I can say that from this set of functional dependency, from this FD set, you can infer this FD. You can derive this FD. Tell me the answer for this question. Tell me. We wish to test whether this FD follows from the given set of FD or not. Tell me. So in this given set of FD, what you will do? What you will find? Please tell me. In this given set of FD, what you will find? Let me know. In this given set of FD, you will find what can D determine? Yes or no? You will find what D can determine. You will find D closure. So D closure will be D. D can determine E. That's it. Yes or no? That's it. So can you notice? That's it. This is your answer. So I can say, can I say D can determine A? Tell me. In this FD set, You can see D does not determine A. D does not determine A. Okay, so tell me, so can I infer this? I can say this cannot be inferred. Yes or no? I can say this FD cannot be inferred, or I can say this FD cannot be derived. So this FD cannot be inferred. Very simple concept, right? Yes or no? Let's move on. So you can see this does not follow. Okay, this FD you cannot infer. Tell me the answer for this question. Consider the relation R, A, B, C, D, E, and the set of functional dependency. This set of functional dependency is given to you. Which of the following set of FDs do not follow from S1? Okay, some FDs are given to you. The question is asking which of the following set of FD do not follow from S2, from S1. Okay, which of them do not follow from S1? So tell me, will it follow from S1? This FD, can you derive from S1? Let me know. From S1, can you derive this FD? So in this S1, what you do? You find out what is AD closure. Just find out what is AD closure. So tell me what that will be. In this given set of FD, you find what AD can determine. So AD can determine AD, D can determine B. Okay, D can determine B. What else? What else? ADB. You can see AB can determine C. What else? What else? Please tell me. That's it. Yes or no? That's it. So tell me. So tell me. Yes, this can be inferred. Yes or no? AD can determine C. You can see that AD can determine C. So actually this can be inferred. I can say this follows. I can say this follows from S1, right? Yes or no? The question is asking does not follow. The question is asking does not follow. Yes or no? The question is asking does not follow. So this is what the question is asking. So this follows from S1. Okay, what about the next one? Tell me. So remember this follows. Okay, there is no problem. This follows from S1. What about AE determining B? So in this S1, what you do? You find what is AE closure. In this S1, you find what AE can determine. So AE can determine AE. Okay, yes or no? And AE can determine D also. D can determine B also. And you can see AB, this A or B, this AB can determine C also. Okay, yes or no? So I can say that A can determine B, correct? A can determine B. So I can say this also follows from S1. I can say this also follows from S1. Okay, this also follows from S1. What about the next? Please tell me. What about the next? What about this next one? This ABC determining D. Can I say ABC will determine D? Here, you find out what is ABC closure. Okay, can I say ABC will determine D? ABC will give you ABC. Yes or no? ABC will give you ABC, that's it. ABC will give you ABC. That's it. So you cannot determine D. Yes or no? You cannot determine D. So I can say this does not follow from S1. I can say this does not follow from S1. Correct? From S1, this does not follow. This does not follow from S1. So the question is asking does not follow. So the answer will be this. Answer will be option C. What about this? Does it follow? Tell me. In the S1, in this S1, you find out what ADE can determine. ADE, what it can determine. ADE can determine ADE. Okay, D can determine B also. Next, you can see AE can determine D. Next, AB can determine C. AB can determine C. So you can see, yes, BC you can determine, right? Okay, correct. You can see we can determine BC. So yes, this follows. I can say this follows from S1. So your answer will be what? Answer will be option C. Is this clear? Answer will be option C. Let's move on now. So you can see if this set of functional dependency is given to you, can you infer A determining H? This is a set of functional dependency I give you. Can you imply A determining H? Tell me. Yes, you can imply A determining H. Okay, you can easily see. Okay, A can determine B, B can determine H transitively. A can determine B, B can determine H. A can determine B, B can determine H. So A can determine H. Okay, so you can imply this. Is this clear? Please tell me. So remember, these words are same. Infer, I can say inferred. This is same as implied. All these words are same. Implied, I can say this is same as your derived. Okay, derived. Or I can say this is same as your follow from. Okay, so something like this. Okay, all these things are same. inferred, implied, derived, and all these things. Now, let me tell you one more thing. This is a notation. Let me tell you one more thing, that is notation. If I give you a set of FD, let's assume this set of FDs is given to you. Let's assume this is S. Okay, this is your set of FDs. Okay, this is the set of FDs that is given to you. Now if some FD, if I give you some FD, if FD, let's assume that, let's call it F. Okay, if FDF can be inferred by S, then how will you write it? Can be inferred by S, then how will we write it? If FDF can be inferred by S, then this is the symbol we will use. Okay, this is the symbol we will use. We will write like this. This is the symbol for inference. This is your inference symbol. That you can infer from S. Is this clear? Please tell me. Let me know. Is this clear point? So remember, if I say that this is your set of FD, you have FD set S, okay, and let's assume you have some FD, a particular FD, okay, you have a particular FD. If you have a particular FDF, okay, then in this situation, what this means, if I write like this, or if I write like this, what this means? Please tell me what this means. What this symbol means? This means, remember, either this you write or this you write. Okay, what they mean? They mean that F infers from S. Yes or no? I can say it means that S infers F. Or I can say F follows from S. Okay, or I can say S follows from S. I can say, or I can say that, sorry, F follows from S. F follows from S. Okay, so all these things are same. Or I can say F is inferred by S. Very simple. Now you tell me, if I write like this, now it means it does not follow. Okay, this is same as does not follow. Means I can say that S does not infer F. S does not imply F. Okay, is this clear? Please tell me. Is this understood? Okay, so quite simple. So this is just a notation, nothing else. This is just a notation. Now, tell me the answer for this question. Given a set of functional dependency, this set of functional dependency is given to you over this relation. This is the relation. Prove that from this set of functional dependency, this functional dependency you can derive. Did you understand this symbol? Please tell me. Did you understand this symbol? What this symbol means? See, this symbol is like this. This is your set of FDs, right? This is your set of FDs. From this set of FDs, prove that you can determine, okay, you can derive, prove that you can derive this FD. Prove that you can derive this FD. This FD you can derive. Okay, this FD you can derive. Is this clear? So tell me, how will you solve it? How will you solve this first part? This part, how will you solve this first part? Let me know. So very simple. What I will do in this F, in this set of functional dependency, remember this set of functional dependency is given to you. In F, what I will do, in F, find what this AG can determine. Okay, find AG closure. Let's find what AG can determine. So tell me, what is AG closure? What AG can determine? AG can give you AG. Okay, AG can give you B also. AG can give you B also. What else AG can give you? AG can give you B also. B itself can give you CD. B itself can give you CD. Okay, this BD can give you E also. BD can give you E also, right? Okay, so you can see that this BD can give you E also. What else you can get? Let me know. This CE can give you F also. This CE can give you F also. So you got F also. Yes or no? So you got everything. A, B, C, D, E, F, G. You got the entire R. Anyway, the point is that yes, this follows, right? Yes or no? So I can say yes, this is implied. Okay, yes, this is inferred. Or I can say yes, this is inferred. Yes, this is implied. Is this clear? Please tell me. Did you understand? So you can see in this given set of functional dependency, this is your given set of functional dependency. From this, you can infer this FD. This FD you can infer. Okay, you can infer this FD. This FD we can infer. Very simple, right? Very simple question. Now tell me about the part 2. What is the part 2? Compute B plus, compute the closure of B. You can see this is the set of all attributes which you can derive. Compute B closure. So tell me, B closure means all the attributes which you can derive from B. All the attributes which you can derive from B. So from B, you can derive B because of reflexivity, trivial functional dependency. So B can derive B. B can derive CD also. So you got CD also. BD can give you E also. BD can give you E also. So you got E also. CE can give you F also. So you got F also. Yes or no? CE can give you F. So you got F also. Can I get something else? That's it. Yes or no? This is your B plus. This is your closure of B. Is this clear? So this is your answer. What about the next one? Find a key of R. The question is asking find a key of R. We have already found, right? So can I give you this as a homework? We have already seen how to find candidate key. When I say key means candidate key. When I say key, that simply means candidate key. Okay. So key means candidate key. So already one candidate key we have found. What was that? If you notice, AG was one of the candidate keys. If you look at AG, that is a candidate key. Is there any other? Is there any other candidate key? Do we have any other candidate key? See, actually, what you can do, just notice which attribute is not on RHS. Tell me which attribute is not on RHS. Let me know which attribute is not on RHS. You can see B is on RHS. See, B is on the RHS. CD is on the RHS. E is on the RHS. F is on the RHS. You can see AG not on RHS. Can you notice A, G not on RHS? If they are not on RHS of any FD, what that means? Of any FD. These are not on RHS of any FD. What that means? So I can say that AG is part of every candidate key. So AG, that is part of every candidate key, right? Yes or no? That is part of every candidate key. Now you can see that itself is enough. Okay, AG is enough. So this is the only candidate key. So remember, there is only one. There is only one candidate key, and that is your AG. That is your AG. Because AG must be part of every candidate key. And remember, AG itself is enough. AG itself is enough. AG can determine every attribute. So I can say this is the only candidate key. Okay, so this is not a homework. We have done it. Okay, so very simple, right? Yes or no? Let's move on now. Tell me the answer for this question. So some functional dependencies are given to you. The question is asking find the closure. Okay, this you can easily do, right? Okay, so this you can do. Now tell me about these one. The question is asking completely fill the circle, means basically fill these circle, fill these circle before the FD. Okay, that is also satisfied by R. Basically, we want that FD which is satisfied by R. Means from these, which FD is satisfied by R? This relation is given to you. Now, out of these functional dependencies, which FD is satisfied by R? Means which FD is inferred? Yes or no? Okay, that simply means which FD is inferred. That simply means which FD is inferred. Okay, is inferred. Which FD you can infer from this set of FD. From this set of FD, let's call it. Okay, let's call it S. Okay, so can be inferred from S. So tell me which FD you can infer. What about this one? Can you infer? What you will do if you want to check, can you infer or not? This functional dependency, can you infer from this? So what you will do, you will check CDE closure. Okay, you will check CDE closure. You can see CDE closure. So tell me what will be CDE closure? CDE closure will be CDE. What else? CDE closure, that will be CDE. Okay, what else can you get? DE can give you F also. DE can give you F also. So you got CDEF. You got CDEF. CDEF you got. That's it. Yes or no? So can I get this FD? Is this FD satisfied by R? Is this FD satisfied by R? No. Yes or no? This FD is not satisfied by R. You can see this functional dependency is not satisfied by R. Okay. What about the last option? Let me check this last option. So what you will do? If you want to check this FD is satisfied by R or not, this functional dependency, is it satisfied by R or not? So what you will do? You will find BED closure. So tell me, what is BED closure? That will be BED. What else you will get? What else you will get? BD will give you C also. BD will give you C also. Now BEDC. BEDC. B can give you E also. Okay, BEDC. D can give you F also. So you got F also. Okay, you got F also. Now you can stop. Yes or no? Can you stop now? Actually, you can stop here. Actually, you can stop here and you can say that, yes, this is correct. This option is correct, right? Correct? Yes or no? You can stop here. But anyway, tell me the complete closure. So you got BEDCF. BEDCF. You got BEDCF. That's it. Yes or no? So this is the complete closure. So I can say option D is correct. Option A is not correct. And the remaining two you can take as homework. Okay, the remaining two you can do yourself. In the private Telegram group, you can discuss. Okay, let's move on now. So this question we have done. Now let's solve this question. This is GATE IT 2005 question. In a schema with attributes A, B, C, D, E, the following set of functional dependencies are given to you. This is the set of functional dependency. Which of the following functional dependency is not implied by the above set? These functional dependency are given to you. The question is asking which of the following functional dependency is not implied by the above set. This is your set of functional dependencies. Let's call it S. So which of the following functional dependency is not implied by this S? So what you will do? For each option, what you will do? Please tell me. Let's check option A. For option A, what you will do? So very simple. See, what you want to find out? You want to find out that this functional dependency, can you infer from S? This is what we want to find out. Yes or no? This is what we want to find out, that from this given set of functional dependency, can you infer this FD? Okay, can you infer this FD? So what is the best way? What is the best way? The best way is, in this S, you find what the CD closure. In this S, you find what CD can determine. Yes or no? In this S, find what CD can determine. Find what this CD can determine. Okay, what this CD can determine means you find what is the CD closure. Can CD determine AC? Can CD determine AC? Okay, our target is AC. Can you get AC? So tell me, what is the CD closure? Very simple. CD can determine CD by reflexivity. Okay, trivial functional dependency. CD can determine CD. What else? CD can determine E also. So CD can determine E also. What else? E can determine A also. So you can determine A also. What else? A can determine B also. So you got B also. Anything else? You can see A can determine C also. You got C already. Okay, what else? B can determine D, that you already have. Okay, that you already have. So anyway, is this cover? Yes, this is the closure of CD. This is the closure of CD. This is the closure of CD. Now you can notice, you can easily see CD can determine AC. That's it. See, look at this. CD is determining AC, right? CD is determining AC. Okay, so here you can easily see that CD closure contains AC. Okay, CD closure contains AC. What it means? It means CD determines AC. Okay, correct. So I can say this can be inferred. Yes or no? Option A can be inferred. But the question is asking not inferred. The question is asking not implied. This is what the question is asking, which is not implied. But actually this is implied. This option A, I can say this is actually implied. This is actually implied by S. This FD is implied by S. Let's see option B. What about option B? For option B, what you will do? Now you will find closure of BD, right? Yes or no? You will find what the closure of BD means. What BD can determine? This BD. What this BD can determine? See, BD can determine BD by reflexive property. This is your reflexivity. So BD can determine BD. What else? What else? You can see B can determine D, that we already have. Okay, so B can determine D, that we already have. What else? Tell me. This BD. What else BD can determine? Let me know. What else BD can determine? Nothing else. Yes or no? BD can only determine BD, nothing else. So I can say that BD cannot determine C. Yes or no? So I can say this FD, this is your answer. Okay, because this is not implied by S. You can see this is not implied by S. What is the reason? You can see that BD cannot determine C. You can easily notice BD cannot determine C. BD cannot determine C. Okay, so I can say that BD cannot determine CD. BD cannot determine CD. So I can say this option B, this is not implied by yes. And the question is asking not implied. So the answer will be option B. Now let's see the option C. What about option C? Please tell me. What about option C? You want to check this FD is inferred by S or not. Means from this S, can you get this FD? Okay, so tell me what you will do. Very simple. In this S, you will find what is the BC closure. In this S, you will find what BC can determine. What BC can determine? See, BC can determine BC because of reflexive property, reflexivity. Okay. Now, what BC can determine? B can determine D. So you got D also. Now you can stop. Do you agree with me? See, you can stop because you can see BC can determine D. You can easily notice that BC can determine D. You can easily notice BC can determine CD. Yes or no? So I can say this option C, this is actually implied. This is actually implied by yes. Okay. But anyway, tell me what is the BC closure? Tell me the complete BC closure. Anyway, tell me the BC closure, complete BC closure for practice. So you can see BC, we got BCD. Now CD can give you E also. So CD can give you E also. E can give you A also. So you can get A also. What else? What else? Please tell me. So yes, we got everything, right? We got everything. Okay. So very simple. So I can say this option C, this is actually implied by S. The question is asking not implied. So the answer will be option B. What about option D? Please tell me. What about option D? Let me know. In this option D, what you will do? You will find AC closure. Basically, you will check in this set of functional dependency, what AC can determine. What AC can determine, this AC, what it can determine. So AC can determine AC. You can see A can determine B. Can you stop here? Can you stop here? Please tell me. Can you stop here? Yes, you can stop here. You can stop here because AC can determine BC. Okay, AC can determine BC. But anyway, tell me the complete closure. Tell me the complete closure. This AC closure. Tell me the complete closure. You can see A can determine C. We already have C. Next, ACB. B can determine D. So you got D also. Next, CD can determine E. So you got E also. So you got everything. Okay. So anyway, I can say this is also implied. So tell me finally, answer is what? So remember, this is also implied by this option. This option is also implied by S. So anyway, the question is asking not implied. So what is not implied? Tell me. The question is asking what is not implied. So the answer will be option B. This is your answer. Okay. Very simple question. Let's move on. Now the next topic is functional dependency, closure of FD set. This is the next topic. What is closure of FD set? If you have a FD set, then what is the closure of this FD set? Okay. This is also very simple topic. Let's see this. What are the closure of set of FD? See, this is the definition. What is closure of FD set? If I give you a FD set, this FD set is given to you. What is the closure? What is the closure? The closure will be set of all FDs that you can derive from this. Set of all FDs which you can derive from this. So for a given FD set S, remember, for a given FD set S, if you have a given FD set S, then the set of all FDs that you can derive, set of all FDs that you can derive, okay, that will be your closure of S. Is this understood? Please tell me. Let me know. So remember, if you have FD set, this is your set of FD. You have FD set F. Then what is F closure? This is your closure of FD set F. This means closure of F. Okay, I can say this is your closure of FD set F. Then tell me what this will be. Tell me what this will be. This will be set of all the FDs which you can derive from F. This is set of all FDs which you can derive from F. Is this clear? Did you understand this notation? Did you understand this notation? So this, what this means? This means F is derived from F. Yes or no? This means F is derived, F is inferred from F. Is this clear? Please tell me. Let me know. Did you understand? Okay, very simple, right? Yes or no? So remember, what is closure of FD set? If you have FD set F, then the closure will be set of those FDs which you can derive from F. Okay, which you can derive from F. Is this clear? Please tell me. Okay, so very simple point. Now let's see. So before we see examples, let me tell you one important thing, and that is in this functional dependency, in the definition of functional dependency, when I say X derives Y, when I say you have this FD, when I say that you have this FD, X derives Y, can X comma Y be empty? Can X comma Y be empty? Tell me. Can X comma Y be empty? Let me know. Let me know. Can X comma Y be empty? Please tell me. Let me know. Can X comma Y be empty? So remember, if you have this FD you have X determining Y, can they be empty? The answer is no. Okay, the answer is no. So remember, these are always non-empty. You can see here. Let X comma Y be non-empty set of attributes. Is this clear? So remember, very simple point, that X comma Y be non-empty. They must be non-empty. They must be non-empty. X comma Y, they must be non-empty. Very simple point. Okay, so whenever you have this functional dependency, X determining Y, then X comma Y, they must be non-empty. Is this clear? So whenever you have this FD, X determining Y, then remember, these are set of attributes. This is a set of attribute, but this cannot be empty. This is set of attributes. This is set of attributes, but this cannot be empty. Okay, so this should be non-empty set of attributes. This should be non-empty set of attributes. Okay, and this Y also, this is also non-empty set of attributes. Is this clear? Very simple. Now let's come to our topic. But before that, one more question I want to ask, that is, are these FDs same? These FDs, are they same? Are they same FD? Please tell me. I'm asking, are they same? These FD, are they same? Are they same? The answer is no, they are not same. They are not same. See what this says. This says that A can determine B. See what this says. Please understand what this means. This means that A can determine B. Means if you have this table, let's assume A, B, C, D, some table you have, then what this says, please tell me what this says. This says that if two tuples have same A value, then that should have same B value. Yes or no? If two tuples have same A value, then they must have same B value. Agree with me? Please tell me. If two tuples have same A value, then they must have same B value. Okay. And what this means? A determining AB. What this means? Please tell me. What this means? Let me know. What this means. On the next page I am putting. So A determining AB. Tell me what this means. This means that if two tuples have same A value, then they must have same AB value. Yes or no? See, remember what this means. This means if two tuples have same A value, if they have same A value, then they must have same AB value. Then they must have same AB value. They must have same AB value. Yes or no? Is this clear? Please tell me, did you understand? So if two tuples have same A value, then they must have same AB value. Is this clear? So remember, these FDs are not same. These FDs are not same. Yes, from this you can infer this, from this you can infer this. I agree. Okay, I agree. From this you can infer this, from this you can infer this, but they are not same, they are different. You can infer. Did you understand the difference? See, A determining B, A determining AB. Notice. From this FD, you can infer this FD. We can infer, right? Okay, we can infer. This is called inference. We can infer this FD. And similarly, from this FD, you can infer this FD. Agree? So you can infer, but they are not same. They are different. This is A determining B. This is A determining AB. Yes or no? They are different. They are different. Do you understand? Please tell me, did you understand? Let me know. Did you understand? So remember, they are different, but they can infer each other. Is this clear? They are different FDs. They are different FDs, but they can infer each other. But they infer each other. Is this clear? Tell me, did you understand? So they are different FDs. These functional dependencies are different, but they infer each other. Very simple, right? Yes or no? Is this clear? Now tell me, what is the definition of closure of FD? Tell me again, you tell me what is the definition of closure of FD? If you have a set of FDs, if you have a set of functional dependencies, let's call it S, then what is S plus? That is your closure of S. And what is that? that is all the FDs that you can derive from S. All the FDs that you can derive from S. Is this clear? Set of all FDs you can derive from S. Very simple. Agree? Is this clear? Please tell me. Let me know. Simple, right? Okay. So now let's find out. Let's find out closure of FD set. Let's see this example. Consider this example. 4 attributes are given to you, and this FD set is given to you. This is the set of FDs is given to you. Now, in this F plus, these FDs will be there. Okay. In this F plus, notice this set of functional dependency is given to you. This is the set of functional dependency. The question is asking closure of F. What is closure of F? What is closure of F? Closure of F means all the FDs that you can derive from F. Yes or no? Closure of F. That means all the FDs you can derive from F. So these are the FDs you can derive from F. Okay. Don't worry, in the GATE exam, they will not ask you. They will not ask you how many FDs you can derive, but you can calculate. Okay. We will calculate. I will tell you how to calculate, but I'm telling you in the GATE exam, they will not ask you. They will not ask you, but you can see that from this FD, if this set of FD is given to you, from this, you can infer these. Okay. All these you can infer. Is this clear? Please tell me. So from this set of FD, you can infer all these FDs. So this is your F plus, means this is your closure of F. Okay. Now let's see how to find out. Now you might be thinking, how can we find out this? Means how can we find out how many FDs we can infer? Yes or no? What is the size of F plus? In the question, if they ask you what is the size of F plus, how to find it? Okay. So let's find it. Very simple. You can do this. Let me tell you how to do this. Always go step by step. Okay. So let's find out. Let's find the size of F plus. Our target is to find size of F plus. Is this clear? What is our target? Please tell me. What is our target? Our target is to find size of F plus. Means how many FDs we can determine. Okay. From this FD, from this set of FD, how many FDs we can infer. So our target is to find size of F plus. So tell me what I will do. I will go in a sequence. Okay. Very step by step. Go in a sequence. Very simple. Go in a systematic way. Go in a systematic way. Is this clear? Go in a systematic way. Go in a systematic way. Now, what you do? First, I will consider when LHS has only one attribute. Okay. So what are the case one I will consider? Case one I will consider when LHS has one attribute, means the size of LHS is 1. Okay. When LHS has only one attribute. Now tell me how many such FDs I can infer. LHS has only one attribute. So LHS can be A. Yes or no? LHS can be B. LHS can be C. LHS can be D. Do you agree with me? Yes or no? Correct. See, LHS can be A. LHS has only one attribute. So LHS can be A. LHS can be B. LHS can be A. LHS can be B. LHS can be C. And LHS can be D. Okay. And LHS can be D. Right. Agree with me? So LHS can be C and LHS can be D. These are the possibilities. Now you tell me, when LHS is A, then you find A plus. First what you do, you find A plus. Tell me what is A plus. Tell me what is A plus. A plus will give you A, B, B will give you C. So this will be your A plus. Yes or no? You will get A plus. Now tell me, how many FDs you can create where LHS is A? Where LHS is A, how many FDs you can create? How many FDs you can create? Remember, this is your closure of A. Now, how many FDs you can create? Tell me how many FDs you can create. Let me know. Here, how many FDs you can create? Please tell me. So you can basically, what you can do, you can put any subset of it. You can put any subset of it. So 7 FDs you got here. You got 7 FDs here. Why? Let me tell you. Okay, don't worry. Let me tell you. See, you got A plus is equal to ABC. This is what you got. Now let's see. From here, let's find out all the FDs. So from here, you will get this FD. This FD you got. This FD you got. This FD you got. 3 FDs, these you got. Okay, what more you can get? Okay, so 3 FDs I got. What more? I got this also. I got this also. I got this also. 3 more I got. What else I can get? Tell me. What else I can get? These also I got. What else I can create? Tell me. So I can also create this FD, ABC. So total how many I got? Total how many I got? I got 7. Yes or no? Is this clear? Did you understand? I got 7, right? Did you understand this question? See, very simple. I want to find the size of closure of F. This set of functional dependency is given to you. Okay, this FD set is given to you. Now, the question is asking what is the closure of F? What is the closure of this FD set? Okay, closure means all the FDs which you can derive. From this, what FDs you can derive? Okay, yes or no? From this, what FDs you can derive? So, what I will do? I will go in a systematic way. To solve this question, I will go in a systematic way. First, I will consider those cases where LHS is 1. Okay, where LHS only has one attribute. So you can see LHS can be A, LHS can be B, LHS can be C, LHS can be D. Now, if LHS is A, I will find what is A plus. A plus is ABC. Yes or no? A plus is ABC. Now, from here, how many FDs I can create? You can see I can create these FDs, I can create these FDs, I can create these FDs. Okay, so tell me how many FDs I can create? Very simple. Any subset of it? Yes or no? Any non-empty subset of it, right? Agree with me? Any non-empty subset of it. Okay, any non-empty subset of it. How many non-empty subset of it? Tell me. You can take any non-empty subset of it. How many non-empty subsets are there? That will be 2 power 3 minus 1, that is 7. Correct? These many non-empty subsets are there. Did you understand? Okay, now you tell me about this one. Okay, so remember 7 FDs we got here. When LHS is A, we got 7 FDs. When LHS is B, how many we will get? First you find B closure, that will be BC. So tell me how many FDs we got here? We got 3 FDs, right? Yes or no? We got 3 FDs. Because what the reason? You can see B plus is equal to BC. So how many FDs I can create? From here, you can see I can create this FD. This is a trivial FD. I can create this FD. I can create this FD. Okay, what I can do? I can create this FD also. So these are the FDs I can create. Yes or no? I can create these, I can create these. So finally, here you can notice what I can do. Remember, any non-empty. So here I can do any non-empty subset. Okay, you can take any non-empty subset of BC. Any non-empty subset of BC you can take. So tell me how many non-empty subsets are there? How many non-empty subsets are there? That will be 2 power 2 minus 1. That will be 3. Okay. Yes or no? Very simple, right? Now tell me, if LHS is C, then what is C plus? C plus is C. How many FDs you will get here? Only one FD you can get. That is C determining C. Only one FD you can get here. Okay. Yes or no? What about this? How many FDs you can get here? If LHS is D, how many you can get? Yes, one you can get. That is your trivial FD. Yes or no? Just find D plus. D plus is D. D plus is D. So you can get one FD. That is D determining D. Okay. Is this clear? So this case 1 is over or not? Please tell me. This case 1, is this over? Yes, case 1 is over. Agree with me? Case 1 is over. How many FDs this case 1 has given to you? How many FDs this case 1 has given to you? 12. Okay, so from case 1, we got 12 FD. Is this clear? From the case 1. Okay, we got from case 1, we got 12 FDs. 12 FDs we got. Now let's see the case 2. What is case 2? Tell me what is case 2? Case 2 is when LHS has 2 attributes. Yes or no? When size of LHS is 2. When LHS has 2 attributes. So tell me, in this, when LHS has 2 attributes, so what is possible? LHS can be AB. Yes or no? If LHS is AB, if LHS can be AC, LHS can be what? LHS can be AD. What else LHS can be? LHS can be BC. Yes or no? LHS can be BD. LHS can be CD. Yes or no? Is this clear? So these are the cases. Please tell me, did you understand? These are the cases. Now you tell me, if LHS is AB, how many FDs you can get? Just find what is AB plus. Just find what is AB plus. What is AB plus? AB plus is ABC. Now, how many FDs you will get? How many FDs you will get from here? Again, you will get 2 power 3 minus 1. That is your 7 FDs. Yes or no? Is this clear? See, very simple. This is your AB plus. AB closer. That is your ABC. Now, how many FDs I can create here? Here, how many FDs I can create? I can create this FD, AB determining A. I can create this FD, AB determining B. I can create this FD, AB determining C. So these FDs I can create. What else I can create? Remember LHS is AB. Remember LHS is AB. I can create this. Okay, I can create this FD. What else I can create? I can create this FD. Okay, what else I can create? Tell me. So these are also done. These are also done. I can also create AB determining ABC. Okay, so total how many? Tell me. Again, very simple. Just create non-empty subset of ABC. So tell me, how many non-empty subsets of ABC? How many non-empty subsets of ABC? How many non-empty subsets of ABC? That will be 2 power 3 minus 1. That will be 7. These many non-empty subsets of ABC. So you got 7 FDs here. How many FDs you will get here? Let me know. So you find what is AC closure. AC closure is AC itself. Sorry, AC closure is ABC. AC closure is again ABC. If you find AC closure, that will be ABC. So how many I got? Please tell me quickly. Now you understood the concept. Now you tell me the answer. You already understood the concept. How many FDs I can get here? I can again get 7 FDs. Very simple. Very good. Tell me what the closure of AD? What the AD closure? AD closure will be ABCD. Yes or no? AD closure will be ABCD. How many FDs I will get here? How many FDs? That will be 2 power 4 minus 1. That will be 15 FDs I will get here. Correct? Very simple, very simple. Now tell me here, how many I will get here? BC closure. BC closure is BC. BC closure is BC. So here I will get 3 FDs. Here I will get 3 FDs. Okay. Next, what about this? BD closure is BCD. BCD, BCD. Okay, so that will be 7 FDs. Very simple, very simple. Now tell me about here. CD closure is CD. So I get 3 FDs here. Yes or no? This is your case 2. So how many FDs case 2 has given to you? How many case 2 has given? Tell me. Do the total. Just tell me what is the total. So you can see 7, 7, 14, 14, 6, 20. Next, 35 and 7. That is your 42, right? Yes or no? That is your 42. Okay, so what you got? You got 42. So in this case 2, you got 42 FDs. Okay. Now, a student is asking, we also have to include repetition. There is no repetition. We did not include any repetition. Okay, all the FDs, these are different FDs. All of them are different FDs. Please tell me, which FDs are same? All the FDs are different. All these FDs are different. All of them are different. Case 1. In the case 1, LHS has 1 attribute. In case 2, LHS has 2 attribute. All these FDs are different. All of them are different. No 2 FDs are same. All of them are different. Is this understood? Please tell me. Many of them are trivial. Yes or no? Can you notice? Many of these FDs are trivial. Some FDs are trivial. Some are non-trivial. Some are completely non-trivial. Yes or no? But all the FDs are different. Please understand. All the FDs that we are getting, all these FDs are different. Some are trivial. Some of them are trivial. Some of them are non-trivial. Some of them are completely non-trivial. But all these FDs, these are different FDs. Okay. Now, what case is remaining? Case 3. Tell me what is case 3. In case 3, what I will do? I will take LHS size is equal to 3. Yes or no? So tell me how many possibilities? LHS can be, for example, ABC. LHS can be ABC. LHS can be, for example, ABD. What else? LHS can be, for example, ACD. And for example, LHS can be BCD. Okay. Now you tell me quickly. Tell me quickly. When LHS is ABC, ABC closure is ABC. ABC closure is ABC. You already know. ABC closure, if you find, that will be ABC. So how many FDs you got here? How many FDs you got here? You got 7 FDs. 7 FDs we got here. How many I got here? Remember ABD closure. ABD closure, that is ABCD. How many I got here? I got 50. 15 here. Yes or no? I got 15 FDs here. Okay, what else? Please tell me. Here what I will get? Again, I will get 15 FDs. Okay, what else? Here I will get how many? Here I will get 7 FDs. So this case 3 has given you how many? This case 3 has given you how many? Please tell me. Let me know. This case 3 has given you 44, right? Yes or no? So case 3. In the case 3, you got 44 FDs. What about case 4? What are the case 4? Tell me, what is the case 4? Let me know. What is the case 4? Tell me. So the case 4 will be when LHS size is equal to 4, means LHS is equal to ABCD. LHS is equal to ABCD. What is the closure of ABCD? Just find the closure of ABCD. Find the closure of ABCD. Find the closure of ABCD. So that will be ABCD. How many FDs I got here? How many FDs I got here? 15 FDs I got here, right? Yes or no? So that's it. So in this case 4, how many? I got 15 FDs. So total, how many FDs I got? Tell me, total FDs, how many I got? That is your size of F plus. That is your size of F plus. So these many FDs you can infer. Can you notice a lot of FDs we can infer? Agree with me? These FDs you can infer. Okay, these FDs you can infer where your relation is ABCD, and this is your set of FDs that is given to you. That is A determining B, B determining C. Okay, is this clear? Please tell me. So if this is the set of FDs, then total FDs inferred. Total FDs that are inferred. You can infer these many FDs, 113. Please tell me, did you understand the concept of F plus? Did you understand? Did you understand the concept of F plus? Please tell me. Did you understand the concept of F plus? Let me know. So what is F plus? Did you understand? Let me know. So very simple, remember, very simple point. Very simple point. This F is given to you. This F is given to you. And these 4 attributes are given to you. Okay. Now what you can do from here, you can find what is F plus. F plus is set of all FDs which you can infer from F. Okay. Is this clear? Very simple. So what will be the size of F plus? The size of F plus will be 113. This is the answer. Simple, very simple. Yes or no? Is this clear? Please tell me. So we have seen the definition of F plus. What is F plus? Closure of F. That is set of all FDs you can infer. Okay, that is set of all FDs that you can infer. That you can infer from F. Okay, so this is the definition of closure of F. In the GATE exam, they will not ask you, don't worry. Okay, you might be thinking, sir, this will take a lot of time. Yes or no? To find the size of F plus, this will take a lot of time. Don't worry, they will not ask you in the GATE exam. There is no question in the GATE exam. Okay, they will not ask you. Don't worry. Now let's move on. This is just the concept that we needed to see. We have seen. Is this clear? We wanted to see this concept. We have seen this concept. You understood this concept. In the GATE exam, they will not ask you the question from it. Okay. Now the next concept is covering. In the functional dependency, the next concept is covering. What is the concept of covering? This is another simple concept. Let me give you a set of functional dependencies. FD set I'm giving you. Okay. Let me consider this FD set F. Let's assume I'm giving you that A determines B, A determines B, B determines C. Okay. Now, what I'm doing, I'm giving you another FD set. I'm giving you another FD set G. I'm giving you this another FD set G, and that is like this. Let's assume that is A determines C, B determine BC. Okay. This is these two sets are given to you. Is this clear? Okay, so remember, two set of FDs are given to you. This is FD set F and this is FD set G. Two FD set are given to you. Now tell me, can I say F covers G? Does F cover G? Does F cover G? Does F cover G? Okay, first let me tell you the definition of what this means. F covers G. What this means? Let me tell you the definition. So first of all, remember, if FD set F is given to you and FD set G is given to you, then what this means? What this means? Remember, FD set F is given to you. This FD set is given to you. Also, this FD set is given to you. Two FD set are given. This is FD set. This is FD set. Two FD set are given. This is also set. This is also set. Okay. So this is set of FDs. This is set of FDs. These are given to you. Now, F covers G. What this means? If and only if. Remember, F is covering G. F is covering G. F is covering G. What it means? It means that every FD of G can be derived from F. Okay. Means I can say F infers every FD of G. F infers every FD of G. Every FD of G. Is this clear? Please tell me, did you understand the definition? Did you understand the definition? Let me know. F covers G. What this means? F covers G. Means this FD set, this covers G. This covers G. Means every FD of G you can infer from F. Okay. F infers every FD of G. Okay. Every FD of G you can infer from F. You can infer from F. You can understand like this. See, you can understand like this. This F covers G. What you can do? You can understand that. What this means? F covers G. This simply means that F implies G. Okay, F implies G. This is how you can understand. Is this clear? F covers G. That means F implies G. Is this understood? Please tell me. F covers G. That means F implies G. Okay, means from F you can derive G. From F you can derive G. Okay, every FD of G you can derive from F. Did you understand the definition? Let me know. Okay, now in this question, tell me, does F cover G? Does F cover G? Can I say F implies G? Can I say F implies G? Tell me. Can I say F implies G? Means, can I say from F you can get every FD of G? From F, can you get every FD of G? From this F, can you get every FD of G? Yes. Yes, you can get. Okay. So from F, you can get every FD of G. How to check? Okay, just look. In this F, you find what is A plus. Tell me what is A plus in F. What is A plus? You can see that will be ABC. So that's it. So this FD you got. So the first FD of G you got, right? Okay, this first FD of G you got. Agree? Is this clear? Is this clear? Please tell me. So this first FD of G you got. This you got. Okay, this you got. Now tell me, can you get the second FD also? The second FD of G, can you get that also? The second FD of G, can you get that? Please tell me. Can you get the second FD of G? Okay, just calculate what is B plus. What is B plus? B plus will be BC. That's it. Yes or no? So I can say that from B you got BC also. Okay, this also I got. So can I say F covers G? Please tell me. Can I say F covers G? Yes, F covers G. You got both the FDs of G. F covers G. Yes or no? F covers G. F covers G. Okay, it's like this. It's like this. Let me give you the analogy. What F covers G means? Let me know. Let me tell you. F covers G. Okay, what F covers G means? This means that this F will say that I am covering you. Means whatever you can do, I can also do. I can do something extra. Okay, F covers G. What this means? Let me tell you. What this means? This means that whatever G can do, F can also do. Yes or no? F covers G. F covers G. Whatever G can do, F can also do. Maybe F can do something extra. For example, it's like this. It's like this. For example, can I say that D-Mart? Okay, you know D-Mart. Can I say D-Mart covers grocery store? Can I say that? Please tell me. Can I say D-Mart covers grocery store? Let me know. Can I say this statement? Please tell me. D-Mart covers grocery store. Yes. Okay, because whatever you have here in the grocery store, whatever you have, that you also have in D-Mart. But can I say grocery store covers D-Mart? Can I say grocery store covers D-Mart? Tell me. Can I say grocery store covers D-Mart? Please tell me. Let me know. Let me know. Can I say this? This is not correct, but this is correct. Yes or no? Agree? Is this clear? See, very simple point. So remember, D-Mart covers grocery store. Why? Because whatever you have here in the grocery store, whatever you have, you can also find in the D-Mart. Okay. But grocery store does not cover D-Mart. In the D-Mart, you can have something extra. Yes or no? So remember, F covers G. What that means? That means that whatever FD you have in G, you can derive from F. Okay. It means that every FD of G, every FD of G can be derived from F. Can be derived from F. Okay. Can be derived from F. F can have something extra. Is this clear? Please tell me. Let me know. Is this clear? Is this clear? So every FD of G can be derived from F. Okay, is this clear? So whatever G can do, F can also do. Very simple point, that whatever G can do, F can also do. Whatever G can do, whatever G can do, F can also do. F can also do. Okay, understood? Understood? Please tell me. Is this clear? Let me know. Let me know. Did you understand this? The concept. Now, in the same question, you tell me, can I say G covers F? Does G cover F? In the same question, you tell me, does G cover F? Can I say G covers F? Let me know. G covers F. Can I say? Whatever you have here, can you derive from G? Can you derive from G? G cover F. G cover F. Whatever you have in F, can you derive from G? No. Here, what is A plus? Here, what is A plus? A plus is AC. A plus is AC. Can you notice A cannot determine B? Yes or no? Can you notice this A cannot determine B? So this FD, G cannot cover. Do you agree with me? This FD, G cannot cover. This FD, G cannot cover. So can I say, does G cover F? The answer is no. Is this clear? Let me know. Did you understand the concept? Please tell me. Please tell me, did you understand the concept? So here, in this example, you can notice, in this example, what I can say? In this example, you can see F covers G. F covers G. Okay, but remember, G does not cover F. But G does not cover F. Does not cover F. Okay, in this question. Understood? So remember, G covers F. What that means? Quickly tell me. G covers F means, sorry, F covers G. What that means? F covers G. That means whatever G can do, F can also do. Whatever G can do, F can also do. Means all these FDs you can derive from F. Okay, all these FDs you can derive from F. So very simple point. Okay, understood? So this is the definition. So you can see this definition, you can read. We have already seen this definition. Now let's move on. Now let's see the definition of equivalence of FD set. When can I say two FD set are equivalent? Can you tell me the definition now? If you have two FD set, you have FD set F and you have FD set G. You have two FD set. When can I say they are equivalent? Tell me. When can I say they are equivalent? They are equivalent. They are equivalent. They are equivalent means they are equivalent. When can I say they are equivalent? F is equivalent to G. F is equivalent to G. When can I say they are equivalent? They will be equivalent if they cover each other. Very good, very good, very good. Okay, they will be equivalent to each other. They are equivalent if and only if F covers G and G covers F. F covers G and G covers F. Yes or no? Okay, yes or no? F covers G and G covers F. Then they will be called equivalent. What it means? It means that, see, whatever G can do, F can also do. Whatever F can do, G can also do. So they are equivalent, yes or no? Whatever F can do, G can also do. Whatever G can do, F can also do. So they are equivalent. This is the definition of equivalence. Equivalence of FD set. If you have two set of FDs, then how can you say that they are equivalent? They will be equivalent if F covers G and G covers F. Very simple. This is the definition you can see. Okay, F covers G, G covers F. Let me tell you another definition. Let me tell you another definition. When can I say this F is equivalent to G? If you have two FD set, you have FD set F and you have FD set G. Okay, so when can I say that they are equivalent? This F is equivalent to G if and only if. Let me tell you the another definition. This is the another definition, that basically F plus is equal to G plus. Yes or no? Basically, every FD that you can derive from this, you can also derive from this. Every FD that you can derive from this, you can also derive from this. So F plus will be equal to G plus. Yes or no? These are the FDs derived from F. Do you agree? Please tell me. These are the all FDs derived from F. These are all FDs derived from F. Derived from F. Okay. And these are all FDs derived from G. Derived from G. If they are equivalent, then this must be same. Do you agree? Please tell me. If they are equivalent, then this must be same. These two must be same. So F is equivalent to G if and only if F plus is equal to G plus. The closure of F that is equal to closure of G. Is this clear? So means all FDs that are derived from F, they must be same as all FDs derived from G. Will you use this definition to solve the questions? If I give you two FD set, will you use this definition to check whether they are equivalent or not? I give you two FD set, and I ask you, are they equivalent? Then will you use this definition to solve? No. This will take a lot of time. Okay, first you will find this closure, then you will find this closure, then you will check whether they are same or not. This will take a lot of time. But this definition can come in the true or false, yes or no? This definition they can ask you in the true false. In the MSQ, they can ask you this definition. So very simple that they are equivalent. What it means? It means that whatever F can derive, G can also derive. Whatever G can derive, F can also derive. Okay, this is your definition. And what is another definition? What is another definition? Please tell me. Let me know. What was another definition? They are equivalent if and only if F covers G and G covers F. This definition we will use. Okay, F covers G and G covers F. We will use this definition to solve the questions. Okay, this definition used to solve questions. We will use this definition to solve the questions. Simple. Okay. Now let's move on now. Now let's see some questions. A lot of practice we will do. So let's see these two. Are they equivalent or not? Okay. Let's see whether they are equivalent or not. So first let me check. Does F cover G? See, the question is asking, are they equivalent? Are they equivalent? This set of FD is given to you. This set of FD is given to you. These are given to you. These FD set are given to you. Now you tell me, can I say F covers G? First you check this. Does F cover G? Does F cover G? Does F cover G? Tell me. So what you will do here? If you want to check does F cover G, what you will do? Please tell me. Does F cover G? What you will do? You will check does F cover G, means can I derive these FDs from F? From F, can you derive FDs of G? Okay, see, this means that from F, can you derive FDs of G? From F, can we derive FDs of G? Okay, yes or no? So tell me, from F, can you derive this FD? What about this FD? First you tell me about this FD. From F, can you derive this FD? So in F, you find what is A plus. Tell me what is A plus in F. What is A plus in F? A plus in F. Tell me. A plus in F, that will be A. A can determine C. A can determine C. AC can determine D. AC can determine D. I can stop here. Do you agree with me? I can stop here, right? I got this. So I got this A determining CD. I got this. Correct? I can stop here. But anyway, tell me the entire thing. Tell me the complete A plus. Tell me the complete A plus in this F. So that will be ACD. That's it. Okay. Yes or no? That's it. Okay. So now you can see, yes, this can be inferred. What about this one? What about the second one? Please tell me. What about this second one? So in this F, again, what you will do? In this F, you will do this. In this F, you will find what is E plus. Tell me in this F, what is E plus? Let me know. So E can derive E. E can derive H. E can derive AD. Okay, yes or no? E can derive AD. A can derive C. A can derive C. Okay, so tell me, did we get? Yes, E can derive AH, right? Yes or no? Can you notice E can derive AH? E can derive AH, right? Yes or no? E can derive AH. You can see this. So tell me. So finally, I can say that, yes, E can derive AH. E can derive AH. That is also correct. So now what I can say, tell me. E can derive AH also in F. Okay, these things are happening in F. So this is also. So can I say that every FD of G you can derive? The answer is yes. Okay, the answer is yes. Simple. So F covers G. So we have seen that F covers G. This is what we have seen. We have seen that F covers G. What about G covers F? What about that? Please tell me. What about the second? Does G cover F? Does G cover F? Can I say G covers F? Let me know. Can I say G covers F? Means what it means? What it means? Can I say that every FD of F you can derive from G? Tell me. So let's check one by one. Okay, one by one we will check. What about this A determining C? Okay, so in G, what you will check? In G, you will find what is A plus. So what is A plus? Tell me in G. In G, you will find A plus. Okay, so tell me what is A plus? A plus will be A, C, D. That's it. Yes or no? A plus will be A, C, D. So tell me. So can I say that A determining C? You got it? This you got it, right? This you got it. Okay, this you got. Now, what you will do? You will find AC plus also you will find. Now you will check this. Now you will check this. So AC plus also you will find in G. In G, you will find AC plus. So that will be what? That will be ACD. Again, you got ACD. So can I say that AC determines D? That also you got. Now, in this G, you will find what is E plus. What is E plus in G? That is EAH. A can give you CD. A can give you CD. So can I say that you got E determining AD also you got, E determining H also you got. So can I say, does G cover F? The answer is yes. Is this clear? So what we got? We got G, F covers G, G covers F. G covers F. So what that means? Please tell me what that means. Let me know what that means. What that means? That means F is equivalent to G. And what that means? Please tell me what that means. Let me know. Let me know what that means. That means F plus is equal to G plus. F plus is equal to G plus. All these things are same. All these things are same. Okay. All of them are same. Simple, right? Yes or no? Very simple. This concept, did you understand? Please tell me. Let me know. Let's solve this question. Quickly, can you tell me the answer? Which FDs are equivalent? Which of them are equivalent? For example, let's check F1, F2. Okay. First, let's check F1, F2. Forget about F3. Forget about F3. Now you tell me F1, F2. First, you tell me, can I say F1 covers F2? What about this? F1 covers F2 or not? Can I say F1 covers F2? F1 covers F2. Means from this F1, can you derive this F2? From this F1, can you derive F2? So yes, this is derived. Okay, this we can derive. See, in F1, from F1, I can derive this. See, from F1, what I can do? Notice. From F1, I can easily derive this. A determining B, that is already there. Okay, from F1. What about A determining C? What about A determining C? Yes, A determining C also. Yes, A determining C also. Okay, so I can say F1 covers F2. The answer is yes. What about F2 covers F1? What about F2 covers F1? Tell me. What about F2 covers F1? What about that? Is this correct or not? Tell me. So from F2, can you get this B determining C? In F2, you find what is B plus. In F2, you find what is B plus. What is B plus in F2? In F2, you find B plus. That will be B only. That will be B only. So you can see that B does not determine C. So F2 does not cover F1. Yes or no? Is this clear? Please tell me. So remember, F1 covers F2, but F2 does not cover F1. So what that means? See, remember, F1 covers F2. Okay, but F2 does not cover F1. F2 does not cover F1. What that means? Let me know. In terms of closure of F1, F2, what that means? Let me know. F2 does not cover F1. What that means? What that means? So this entire thing, what that means? That means that F1 is more powerful. Yes or no? I can say F1, F2 are not equivalent. Of course, they are not equivalent. Of course, they are not equivalent. But to tell me, which closure is superset, which closure is subset? Tell me. Which of them is superset? Yes, this is proper superset. Yes or no? Basically, here you have more derived FDs. Yes or no? Basically, here you have more FDs you have here. Here you have more FDs. Okay, I can say here you have more FDs. Is this clear? Very simple, right? Agree? Is this clear? And of course, F1 is not equivalent to F2. F1 is not equivalent to F2. But you can see that F1 plus, that is proper superset of F2 plus. Proper superset. This will be proper superset of F2 plus. Okay, is this clear? Tell me, please tell me. What about F2, F3? Let me know. Quickly tell me. Forget about F1 now. What about F2, F3? Tell me. Can I say F2 covers F3? Quickly tell me. Can I say F2 covers F3? This F2, is it covering F3? See, F2 covers this. This is fine, right? Yes or no? A determining B, no problem. No problem. Okay. From F2, now you find AB plus in F2. What is AB plus in F2? Please tell me. In F2, what is AB plus? We are finding in F2. Okay, in F2, we are finding. So in F2, what is AB plus? In F2, AB plus will be ABC. This will be AB plus. So can you notice AB determines C? So F2 covers F3. The answer is yes. Is this clear? Please tell me. Is this clear? Because you got this. You got this. Okay. What about F3 covers F2? What about F3 covers F2? Please tell me. F3 covers F2. What about that? Is that true or not? Can I say F3 covers F2? See, in F3, can you get all the FDs or F2? In F3, you got this. There is no problem. Now, in F3, you also find A plus. What is A plus in F3? What is A plus in F3? In F3, that will be A, B, C. Okay, so you got this A determining C also you got. You got A determining C also you got. So you got both of them. So the answer is yes. So the answer is yes. Okay. So the answer will be here. Yes. So they cover each other. What that means? Please tell me what that means. What that means. So remember F2 is equivalent to F3. I can say F2 is equivalent to F3. They are equivalent. Okay. And we know that F1 covers F2. F1 covers F2. But remember F2 does not cover F1. F2 does not cover F1. Now from this, can you tell me the relation between F1 and F3? Please tell me. Does not cover F2, F1. Okay, now you tell me. Now from this, can you tell me the relationship between F1, F3? Yes, they also will be not equivalent. See, because F3 is equivalent to F2, means they are basically same. Yes or no? They are basically same. They are basically same. F2, F3. So F1 covers F2. So F1 covers F3 also. Of course. So F1 covers F3 also. And F3 does not cover F1. And F3 does not cover F1. Is this clear? Simple, right? Yes or no? So you don't have to solve. This F1, F3, you don't have to solve. You can easily see F1 covers F3. F3 does not cover F1. Okay, very simple. Tell me the answer for this question quickly. You are expert now. Very easily you can do. First to tell me, FD1, does it cover FD2? First to tell me, FD1 covers FD2. What about this one? Can I say FD1 covers FD2? This statement. In this FD1, can you get D determining C? In this FD1, can you get D determining C? Just find what is D plus. Just find what is D plus. D plus will be D, A. Okay, A can give you B, C. Just find D plus. D plus will be D, A, B. AB can give you C. Okay, and you can get this D can give you this. Right? Yes or no? So you got everything. So I can say that here I got what? I got A determining D determining C I got. Okay, no problem. I got D determining C. That I got. What about A determining BC? What about A determining BC? In FD1, you find what is A plus. Tell me what is A plus. A plus will be A, B, AB can give you C, yes or no? In FD1, that is your A plus. A plus is AB, AB can give you C, that's it. Okay, so we got this also. So I can say A determining BC also we got. Now in this FD1, you also find what is D plus, that you already have. So you got D determining AE, that also you got. Okay, you got D determining AE. So we got everything. This also we got, this also we got, all these three we got. So FD1 covers FD2. The answer is yes. The answer is yes. What about FD2 covering FD1? What about, can I say FD2 covers FD1? Please tell me. Can I say FD2 covers FD1? What about this? What about this? Let me know. FD2 covers FD1. See, in this FD2, now in this FD2, you find what is A plus. What is A plus? A plus, that is A, B, C, that's it. So can you notice in this FD2, remember, in FD2, what we got? We got A determining B, we got, yes or no? We got this FD. This FD is done. This FD is done. Okay. Now in this FD2, you also find what is D plus. What is D plus? That will be DC. That will be DCAE, and A can give you B. So you can see that in this FD2, you got D determining A. That also you got. This also you got. This also you got. Okay. Is this clear? This also you got. And you can see this also you can get from here, that AB will determine C. Here you can notice that AB will determine C. Yes or no? That AB will determine C. So this also you got. Okay, these three you got. What about this? This also you got, right? Okay, so D determining BE, D determining BE. This also you got. So you got all of them. Yes or no? Is this clear? Please tell me. You got all of them. Means FD2 covers FD1. The answer is yes. The answer is yes. So finally, what is the answer? So remember, FD1 covers FD2 and FD2 covers FD1. So determine if they are equivalent. The answer is yes, they are equivalent. Okay, yes, they are equivalent. This FD1, this is equivalent to FD2. And what that means? Please tell me what that means. Let me know what that means. That means their closure, if you find their closure, that will be same. Okay, if you find what are the functional dependencies derived from them, they will be same. Their closure will be same. Their closure will be same. Very simple, right? Yes or no? Can I give you this question as a homework? Consider a relational schema ABCD with functional dependency. This is the set of functional dependency. Which of the following functional dependency set is equivalent to F? This F is given to you. You need to find out which of them is equivalent to F. You can do this, right? Yes or no? You can easily do this. You can discuss in the private Telegram group. Okay? In the private Telegram group, you can discuss this question. Very simple question. I hope you understood. Okay, so this is your question. You can do it. The answer is also given. If you want, you can check it out. The answer is also given, but you do it yourself. Okay, so that's it. This is your chapter. So did you understand everything? Please tell me. Did you understand functional dependency? In functional dependency, everything did you understand? Please tell me. Every concept, every small point, did you understand? In the functional dependency chapter. Please tell me. Anyone has any doubt? Let me know. Anyone has any doubt? Please tell me. Okay. Thank you, everyone.